Stop guessing sales and speed limits. Use Algebra. Whether you're calculating a discount, converting miles to kilometers, or scaling a recipe, ratios and percentage are everywhere. In this lesson, we'll break down ratios, proportions, and percentages. The math that makes sense of real life. You'll see how a simple proportion can turn chaos into clarity. So, if you ever wondered how 20% off really works or why your speed kilometer seems to lie, stick around. Let's make numbers practical right here on our channel. My name is Mahmoud Kiasari. Welcome to Special K. Hello everybody, hope you're doing well. My name is Mahmoud Kiasari and welcome to Module 6, which is going to be about the ratios, persons, and proportions. So today at this module, as I just mentioned, we are going to talk about different kind of concept like the percentage, and when we are talking about different kind of conversion. For example, when we are talking about the kilometer per hour, or when we are talking about the ratios, what actually we mean. So let's just start this part with the fact that at this point, we are going to stop guessing sales and speed limits, and we are going to use the algebra itself. So at this point, first of all, it's very important thing is the difference between the ratios and rates. So let's have a big picture that what is actually happening between these two. So whenever you hear something about the ratio, for instance, we said that the ratio of number of apples over the number of oranges is 3/2. So what does it actually mean? A ratio means that we are trying to compare some kind of have the comparison of the same units. It means that when we are talking about the oranges and apples, actually we are talking about fruits, right? So at this point, yes, we do have two different kind of fruits, but still we are trying to compare them, see that what is the proportion or what is the ratio of one in comparison to another. On the other hand, when we do have rate, actually we are going to compare of different units. For instance, when you look at your kilometer and the car itself, we said that, for example, kilometer per hour, actually we are trying to compare the distance over the time itself, which is kilometer per hour, and we got it as the unit measurement. So at this point, we do have the ratio. Again, it's a comparison of same units. For example, the rate over blue is 3/2. Again, I'm going to talk about why we use this kind of units, so don't worry about it. After that, we do have the rate. It's a comparison of different units. For example, kilometer per hour, and the ordinary units over here is matter. So for the next time, if somebody tells you that, well, what is the 120 beats per minute? As you can see, I do have bits and I do have minutes. So at this point, is this guy a ratio or rate? Since we do have two different units, it means that this guy is going to be the rate itself. As we know, the ratio is a comparison of two different parts which they have the same unit itself. So as we all know, in order to show the ratio, percentage, the rate, any other some kind of measurement variables in our world, we have to have a way to show them, right? So at this point, we do have three different ways to show the ratios itself. So the very first way, A is the number that we do have at the first one, and B is the second one. For instance, when we are talking about the ratio of apples over oranges is 3/4, so this guy is going to be considered as apple, and this one is going to be considered as oranges itself. On the other hand, we can use the same one as 3/4. Instead of just using 3/2, we can use 3:4. And also we can use the 3 dash itself in order to show that how is that difference. So at another point, we do have the simplifying ratio. So what does that supposed to mean? So if you guys remember from our previous video, and for some of you that don't remember that, I highly recommend to look at our fraction video. So when we do have fractions, for example 4/6, it doesn't necessarily mean that 4/6 is just going to be equal by itself. At some point, I can find a number that if I can divide or multiply by denominator and denominator at the same time, I can make another fraction. So we call these two fractions as equivalent fractions, or we can say I do have a fraction and I can simplify it. Since the ratio is somehow working with fraction, we can do the same thing over here. It means that when I do have a ratio of 8/12, if I can find a number that both of denominator and denominator can be divided by evenly, I can have another fraction. It means that these two fractions are going to be the same. Why? Because the ratio of numerator over denominator is still the same itself. So again, we had three different ways in order to show the ratio. We had A to B, we had A colon B, and we had A divided by B or the fraction wise. So at this point, order matters. Be careful. First quantity goes first. So after that, we do have the simplification by dividing both parts by their greatest common factor. It means that we can find a number, and if we simplify them, or if we divide both of them by the same number, we can find another fraction that is going to show the same ratio itself. So as I just talked about it, equivalent ratios and scaling is another way that we can convert fractions together, since ratios is all about fractions. For instance, when I do have 3 over 4, or I do have 3 to 4, I can multiply both sides by 2. I can multiply denominator and denominator by 2, and I do have a new one, or the new ratio. Or in the meantime, if I do have 6 over 8, I can divide both sides by 2, and still I do have the same ratio itself. So it means that it is important I can multiply or divide both parts equally itself by both part and denominator, and I can create a proportionally identical comparison. So there's a very common pitfall is that you cannot add or subtract both parts. The only thing that you can do is scale. So at some point it happens that you would say that, okay, so I can do the multiplication and division, why not addition and subtraction? Because if you guys remember again from the fractions, for adding and subtracting, first of all, we have to make sure that both of those two numbers, for example, when we do have a fraction and when we do have a number, we have to make sure that number is going to be converted to fraction, because in that time only we can do the addition and subtraction. Also, we have to make sure the next one, or the number that we just converted to a new fraction, has the same denominator as the first one. So please be careful. So let's have this example. Is 9 over 12 equivalent to 3 over 4? It means that is there any number that if I divide that one by numerator and denominator, I can still get 3 over 4 or 3 to 4? That's right, I can. So if I divide both sides of the numerator and denominator by 3, I can have this one. In the same time, if I multiply both sides of this by 3 and 3, I can have this one itself. After that, we do have the proportion and the cross multiplication. So again, proportion means that two ratios are equals, right? So we are going to use cross products in order to solve a couple of equations, and we will see in the future how we can use them. But at this point, let's talk about the fact. If I do have two ratios, if I do have two fractions, and those fractions are going to be equivalent, for example, a over b is equals c over d. At this point, I can say a times d, which means that the denominator of the next one is equals b times c. Is going to be the denominator of the second one and denominator of the first one. Let me give you an example. If you guys remember, for the last part we had 9 divided by 2 is equals to what? Or equivalent to 3 over 4. So let's see that this rule works or not. So it means that if I multiply 9 by 4 and if I multiply 3 by 12, on both sides of equations I do have the same number. So 9 times 4 is going to be 36. 3 times 12 is going to be 36. So these two guys are equal. So I can say that the cross multiplication is this one. It means that I can multiply these numbers together is working. So when we are trying to use this, actually we are trying to find the missing part. So at this point we didn't have any missing part. But let me give you an example that actually we do have something and we are looking for that. So imagine that you have a question, and the question would say that I do have two fractions, or I do have two ratios, and I know I do have two rates, and I know for a fact that x over 6 is equals 8 over 3. Find x for me. So based on the cross multiplication, we know that 3 times x equals 8 times 6. So by doing the calculation, as we all know, the only thing that we have to do is just divide both sides by 3 and this side by 3, because we are going to solve the equation based on x, if you guys remember from the previous one. By doing the calculation, I know for a fact that x is equals to 16. And the only thing that we can check that is put 16 over here, and we see that we are going to have the same fraction itself. So let's talk about the percent. So what does mean percent? Percent means per 100 type part, and we do have it as the whole, or as the part over the whole itself. So let me just give you a very simple example. Imagine that you do have some kind of 100 apples, and you have this 100 apples, you got 20 not very good quality apples. So if I ask you that how many percentage of these apples are actually good, what would you say? So you know the fact that there are 100 apples, it means that that's a whole, and the part that actually is good is 80, right? So the only thing that you can say right now is 80 divided by 100. So this is the way that we can do that. Or we can just move one step further and say that 80 divided by 100 is 0.8. And 0.8 actually can be converted to percentage. How? By multiplying by 100. So by that one, I know for a fact that 80% of all of my apples are in good quality. Again, we talked about it in Math 01, but right now I'm going just to mention that because it is just most likely a fact. But in the future slide, you can see that how we can use this fact itself. So again, the definition of percent was the part over whole itself, but we have to remember after that we have to multiply that by 100. For instance, at this point when I do have the number as 0.25, it means that for instance the ratio of my good apples over the whole apples is 0.25. Actually, how I got that 0.25 multiplied by 100 is going to give me 25% itself. So use the triangle memory aid. This is another way that you can some kind of remember about that one. So for instance, when we say that the one is 17% of 200, so actually we are looking for a specific number. So 17% means the percent itself. 70% or 0.17 or 17 over 100. It means that if I know for a fact that I do have 100 of something, 17 of that 100 is the thing that I want. So imagine instead of 100, I do have 200. How can I find that? Simple. 17% or 17 over 100 should be multiplied by 200. So part equals to my percent over the whole itself, and I do have it at 34. So this was the very simple definition of percent itself. So let's try to expand this fact that how we can use the percent. Obviously, you just go to the store and sometimes you see some product and see that, oh my God, it has a discount. And in the meantime, you see that, okay, how I can find the discount itself and how I can make sure that how much this guy has discount. Or maybe we can have another question. And I know for a fact that the price of this product was something, and after discount, the price got to another number. So right now I want to find that how much was the discount actually itself. So we do have the very some kind of simple formula for that. The change or the percentage of change, percentage of change equals to new number subtracted by old divided by old times 100% itself. Imagine that I had a product that it was $50. Well, after some points, because of inflation, that product got $65. So obviously I had some increase for a fact that change was positive. So right now I would like to find that how many percent that change was. So the only thing that I have to do, I have to consider my new value, 65, subtracted by 50, which was old one, divided by 50 times 100. So I got 30% itself. On the other hand, if I do have a product that was $80 and I had discount, that discount made that specific product to $60. Right now, I would like to find the discount itself. So obviously the discount was negative, or when we are saying, like, for example, 25%, 30% of discount, actually we are talking about the negative or decreasing number. So at this point, my new number is 60 subtracted by 80 divided by what? Divided by the old number, which was 80 itself. So I do have negative 25%. So at this point, I can find my percentage itself. So again, when we do have increase, it means that the result is positive percentage. When we do have decrease, the result is negative one. So be careful, base must be the old value, not the new value, which is a very, very common mistake. So imagine that I do have a point, or I do have a product that it just increased from $80 to $91. What is the percent of the change? First of all, we know for a fact that it was increasing, right? So the percentage, it should be positive itself. From 80 to 92, it was 12 points of changes. So my new number subtracted my old number divided by my old number itself. What was my old number? The old number was 80 times 100%, and I got 15%. I know for a fact that this one was increased by 15% itself. So imagine that you are going to a store, and instead of just seeing one discount, you see two discounts back to back. So maybe it's a very common thing. You say that, okay, I do have a 50% of discount. Again, I do have another 50% of discount. So right now I do have 100% of discount and everything is free, right? No. So you have to make sure that the first discount is fine. The first 50% is okay. But when we say that the next discount, actually that one should come up after the second one. You cannot add them up. The only way that you can do it is just multiply those discounts together in order to make sure the total number got how much a percent of discount. So I can give you a very simple formula for that. Imagine that you are going to a restaurant, or we are going to a store, and you have clothes and you see two discounts back to back. So in order to find the final value, you have the old price times 1 minus D1 times 1 minus D2 or times 1 minus D3 is based on how many discounts that specific product has. D1 is the percent or the percentage of the first discount, and D2 is the percentage of the second discount. So at this point, when I do, for instance, I do have 20% over here, and when I do have 30% over here, at the end, the discount would be based on this. So be careful, we are not going to say that we have 20% discount and after that we have 15% discount, so at the end we do have 35%. No, because if we do this calculation just like this one, I do have 20% discount and then I do have 50% of discount. So the price should be times by 1 subtracted by 0.2 and was times 1 subtracted by 0.15. So at this point I do have my price times 0.68. 0.68 means that actually 1 subtracted by 0.35. I'm sorry, so 0.32. So it means that at this point I do have 32% of discount. And unlike the one or the common mistake that we have is not going to be 35 itself. So imagine that I do have 20% and 50% of discount. Is it going to be 35%? No, we just saw that it's going to be 32%. So please be very careful. That is very important. Another thing that we can talk about it is about scale of drawing and map. So obviously you know why we have that. Imagine that you have a map of your house, and you saw that one, and after that you saw some numbers or some scales. It means that, for example, 1 centimeter to 0.5 meter, and you just wonder, okay, what's going on? So if you want to draw a map, obviously you cannot draw everything on the right scale and as the way it is. Imagine that you have a room is, for example, is 5 meters by 5 meters. You cannot have only 5 meter by 5 meter and put it only for your room on a map. The map is just piece of paper. So we have to make sure that we're going to scale down everything with one specific, some kind of value, because we don't want to ruin the balance. And after that, based on that one, anyone can read that and it will say that, hey, from this point is 2 centimeter. Based on the scale, I know each centimeter means 0.5 meter. So 2 centimeters times 0.5 meter is 1 meter. And she or he knows that for a fact that specific part is not 2 centimeter. It actually was 1 meter itself. Because again, we are trying to save some space rather than just saving or some kind of storing all of those big papers, because of should be as the same, their value should be as the same as the one that you have inside your room. We are going to scale it down, right? So let's talk about it a little bit over here. Again, as right now, I do have this one. I believe you saw it in the map, or you can just Google it. You see that how the scale look like. So I do have 1 centimeter, I do have 0.5 meter. At this point, it means that each centimeter of drawing actually is 0.5 meter in the real world itself. So for instance, I do have a drawing, and after that, that drawing has 4 centimeter, and the scale is 1 to 100. So what is the real length? It means that each centimeter in my some kind of writing or drawing is going to actually be 100% smaller than the real work. So if I would like to find the real value, I have to times 4 by this one or by 100, and I do have 400 centimeter or 4 meter. So another thing that we have to know is about the unit conversion. And a very common unit conversion is about kilometer per hour to meter per second. Again, when we are talking about that, actually we are talking about 2 different numbers. So on the top we are talking about distance, on the bottom we are talking about the time itself. And we do have a very some kind of common formula. If you would like to convert to kilometer per hour to meter per second, you can divide both sides or some kind of divide that specific number by 3.6 and you have your meter per second. So for proving this fact that why we do have 3.6 is so easy. Why? Because as we know, each kilometer actually is 1,000 meter and each hour is 3,600 seconds. So by using this fact, we can reach to a number which is 3.6, and by dividing that number, by dividing the kilometer per hour by that number, we can get meter per second. And if we do the vice versa or multiply the meter per second by 3.6, we can find our number itself. So again, when we do have a 90 kilometer per hour, actually we mean 25 meter per second. So thank you guys for being here with me, and so far we talked about different kind of ratio, the rates, the percent, what are the difference, how we can use it in the real world, especially when we are talking about discount and discount. We had the conversion. Again, the conversion that we had was simple because we only try to mention a couple of things for you guys to refresh your mind. After that, we are going to use it in some kind of a much more detailed and challenging some kind of questions in order for you guys to completely understand. So for the next module, we are going to see that how we can actually use all of those understanding in a real question and get some numbers. Again, if you like this one, please like and comment. My name is Mahmoud Kiasari and this is Special K. Have yourself a great day, night, whatever. See you around.